Good morning, everyone. It's a great pleasure to be on stage with Kaushik Da. I learned yesterday that he joined Delhi School in 1978. Actually, I came to Delhi School in 1978 as a master's student. Kaushik Da was taught us microeconomics, and I was also fortunate enough to be his tutorial group. And I have to say that, I have been in many universities as a student, but I have really not come across a student who taught with so much clarity and with so much enthusiasm as Kaushik does. So it's a great pleasure. I don't want to spend any more time on this, but let me make you aware of certain things that you may not be aware of about Kaushik Da. So he shares an important trait with the 20th President of the United States, James Garfield. And you may ask what? And both of them have a published paper on a new proof of Pythagoras' theorem. Right. Many of you may also not know that he has a published paper on the best way to traverse distances in Rajiv Chowk. It's a very nice paper. And so we all look forward to your talk today, Kaushik Da, and thank you.
Thank you very much, Sudhir, Rohini, Arunava, and Ram Singh for the invitation. It's an absolute pleasure to be here at the Delhi School of Economics. I say this with no exaggeration. Just coming in through the gates of Delhi School of Economics for me is emotionally overwhelming. It's 17 years. Actually, I joined in 77 as a visitor, and then from 78 with a regular appointment. Completely a part and parcel of my life, and some of the absolutely best years for me were at the Delhi School of Economics. Let me, the topic today that I will be covering, I'll give you a gist, which is, it's called the knowledge curse. It's a rather surprising result about how knowledge can backfire on us, which is the core of the paper. It's a very, very simple argument, maybe a bit more theoretical than one does in public lectures, but for that Ram Singh is to take the blame. I was giving him some topics. He was very keen I speak on this one, and this is very exciting for me because it is very, very contemporary research. The paper has just been published this month. That will be the core, and then other knowledge related things, and I'll end with something which is extremely important, which is what do you do about these kinds of negative, surprising results? What are prior actions, prior agreements among human beings to avoid these kinds of knowledge curse? Or I've worked on a couple of other related things which I will present. But first, let me just also say a few things about the Delhi School of Economics before this is the 75th year. This is really, when you go out from here to the rest of the world, you realize that the quality of the students, the quality of the interaction was absolutely comparable to any place. The top end of the class is the top end of the class anywhere in the world that you will get, and it was very palpable. And the people who were here, more or less at the same time, my PhD advisor Amartya Sen, Jagdish Bhagwati, K.N. Raj, Manmohan Singh, it's amazing to think of an institution that has this kind of quality and presence. And for me, it's an integral part. Became even more so when setting up the Center for Development Economics that Pulin Nayak and I ran around. There were times when we felt it's not going to take off, will not happen. Back and forth, one incident which to me is delightfully stuck in my head. We would write letters to bureaucrats, try to contact them, no response, nowhere. Finally, very sheepishly, the finance minister, Dr. Manmohan Singh, whom I barely knew, I sent a letter pleading that can I come once and talk to him about what we were trying to do over here. To my surprise, got an appointment. So went to the Ministry of Finance, and you're going to meet the finance minister. So I went 15 minutes early, and uncharacteristically for Dr. Manmohan Singh, he was 15 minutes late, which meant for 30 minutes I was in his waiting area. I kept sitting there, and one bureaucrat who was not responding to any of my phone calls or requests was passing by, poked his head in and said, "What are you doing here?" That time I used to teach in Delhi school, that's all he knew. I said, "Well, I've come to meet the finance minister." He seemed a bit surprised, went away. After that, he would respond immediately. Any phone call, any message, he would respond. So much so that I was very, very tempted that I would contact the finance minister once again and plead with him if I could come once a week to him. But I would assure him that I would not disturb him at all. He would just wait in his sitting area, be seen by the bureaucrats who take decisions, and come back to Delhi school once a week, half an hour there. Would be very productive. But things moved after that, very supportive, and there are lots of little nuggets, but I can't take away time just now for that. So let me just move on. The knowledge problem. Knowledge, in a place like the Delhi School of Economics, we put it on a pedestal. Knowledge is all good. Scientific breakthroughs are all for the better. And of course, most of the time, almost all the time, maybe they are for the better. But there can be situations where the breakthrough of a knowledge turns out to be a curse. Some of these we know very well, we understand that. And I will give some illustrations. If you discover a new bomb, the nuclear weapon, it's a breakthrough in scientific knowledge, but it can turn out to be a curse that you've done it. That's a rather obvious one. The core paper on which I'm giving my talk, though after that I'll get into some work I've done on moral responsibility, but the core paper, which has just been published in Royal Society Open Science, is joint work with Jürgen Weibel. The paper happened, and I'm only at the Delhi School of Economics, I can say this, which for both Jürgen Weibel and me was very exciting. He was visiting Cornell, and literally in front of a blackboard, we were with chalk talking about, can knowledge backfire? What ways in which knowledge can backfire? And we were writing down little numbers and things on the blackboard when we suddenly discovered an unusual way which we had not expected, that knowledge can backfire on society and leave us worse off. That is what I'm going to illustrate to you and then get into other matters. See, the sorts of questions that immediately come up is, if in a society some people are knowledgeable and the rest are not knowledgeable, is there a knowledge advantage? And the answer is virtually always the case, especially if it's one person knowledgeable. That person has an advantage vis-a-vis the others. If it is a Robinson Crusoe economy with only one human being there, if you discover a new way to purify water or light fire, it can only be to your advantage. Barring, we know, behavioral economics, it can cause your utility function to get messed up, but if that does not happen, it can be to your advantage. Some kinds of knowledge, when you have a society with people who are ignorant, and some people are knowledgeable, very often you will not be able to make out what is leading to the action of the knowledgeable person. And different manifest actions can hide behind it different levels of knowledge, totally different motivation, but the same superficial behavior causes problem to other people. One completely trivial story, but it's a delightful story, I love it, which shows how superficial behavior, being perfect, can hide a very different reality behind it. The story is, and needless to say, it's made up by someone. An American economist goes to China and is giving a public lecture like this, lots of Chinese students and professors sitting, and he was thinking whether he will tell them a joke, which is a very complicated joke. So he's a bit worried. Can it be translated? Will they follow? But he tells them the joke, and the audience roars with laughter. He's very pleased that amazing education in China and intelligence that people followed this complicated joke. In the evening at dinner time, he's with his Chinese friend, and he says, "You're a dear friend of mine, explain to me, how did the translator manage to translate such a complicated joke?" To which he said, "You're a friend and I can tell you." The translator translated it as follows: "The American economist is telling you a joke, laugh." And the behavior was, of course, perfect, and he was taken in, but the motivation was completely different from what he thought. This, of course, begins to play a role when you have knowledge. The knowledgeable person can emit a particular kind of behavior. What I will do straight away is to take you into the, let me just make sure I'm moving the right thing. I've gone over the motivation. A picture of John Nash. The equilibrium notion that I will use throughout is Nash equilibrium. Almost all of you will know it, but even if you don't know, don't switch off, please, because I'll explain the notion clearly enough that you'll be able to follow the equilibrium notion that I will use. The base game. The game that's going to drive the result, and this is really what we had worked out on the blackboard, is a game where there's one player choosing between the rows and another player between columns, and let me explain so that throughout you read it. You read it right. Yeah, it's fine. So I'll refer to the player choosing between the rows as player 1 and the player choosing between the columns as player 2. 2 has to choose between A and B, 1 has to choose between A and B, and the payoffs are throughout. This is the convention, this is standard convention. The left-hand number is what this person gets, the right-hand number is what that person gets. Throughout the table, that is the case. In this game, these are the payoffs. Treat them as rupees or dollars or whatever it is. You can probably see very, very easily what the Nash equilibrium is. In this case, you don't even need Nash because it's a simple dominant rationality choice. Let me just show you. If the player choosing between columns has chosen A, what will the player choosing between rows do? 53 is better than 52. So if the other person is choosing A, I will choose A. If the other person is choosing B, I'm restricted to this column. That does not matter. But 51 is better than 50. So I will again choose A. Therefore, it's like a bit like the prisoner's dilemma the other way around. No matter what the other person does, for me, A is the superior action. Completely symmetric game. You can go through that. A is the superior action for the other player. You will both choose A, and you will get 53 each. $53 or 53 rupees each of you will get. That's the equilibrium. In this case, that is the Nash equilibrium. But there are tons of different equilibrium notions in economics. This is such an obvious equilibrium that virtually all equilibrium notions will tell you AA is the outcome. It's a dominant strategy. I have to be utterly foolish to do anything else. One way in which one kind of knowledge breakthrough that can make society worse off is if a new action is discovered, say action C, like a bomb. We've discovered a bomb, and I'm referring to, of course, many of you would have watched the film and had your memory refreshed. Oppenheimer talking about the world which is transformed with the discovery of the atom bomb, and it would be used by August. The bomb would be used twice. Transforms the world, and for the worse, very likely, but I'll give you. A new action can make it a worse world. Very easy to show. So that's not the knowledge curse that is of interest to us. It is true, but it's very obvious, which is the following. Remember, my base game was this part was the base game. Now let us say a new action is discovered called action C on the part of the other player. And if you look at the numbers, you can see that now there is a dominant strategy for player 1, play C no matter what the other person does. And symmetric game for player 2, play C no matter what the other person does. The equilibrium is going to be CC. This is basically the prisoner's dilemma with a slightly more complex superior 2x2 set. It's a prisoner's dilemma got created by the arrival of a new strategy, obvious enough. What got us excited was, go back to this game, don't allow any new action to be discovered. Science and scientific knowledge now is literally like what many, many big theorists have done, and we call this arrival of Galileo. The person helps you understand where the payoffs are coming from. These payoffs, by the way, are expected payoffs throughout, that's my assumption, which means not that you will always get 53 if you choose A and the other person chooses A, but your expected payoff is 53. It can be higher, it can be lower, but expected payoff, and assume risk neutrality on the part of all agents. So given those expected payoffs, the game is exactly what I described. Now, a scientific breakthrough happens. Galileo, we call this after Galileo, and Galileo says that, look, you get some fluctuations in these payoffs, but now I've understood what the fluctuation comes from. You can describe a more basic game which has to do with the position of the moon. And this is what Galileo's finding is. Moon, if it's in state 1, and if you choose AB and the other person chooses AB, those are the payoffs. The moon, if it is in state 2, these are the payoffs. And it's very easy to check that if half probability moon will be in state 1 and half probability moon will be in state 2, the payoffs, if you put these together, you are going to go to the top, back to the basic game. The base game that we had is nothing but a construction of moon in state 1 and moon in state 2, half probability each, half probability 4. If both of you are playing AA, half probability you'll get 4, half probability you'll get 102, expected payoff is 53. The entire base game is constructed with half probability moon in state 1, half probability moon in state 2. But now the trouble is, if this knowledge becomes common knowledge, Galileo arrives, Galileo announces that, look, these fluctuations, I can tell you a little bit of what's happening. Look up at the moon, and you will have a sense of where the fluctuations are coming from. It's a transformed world, because after the arrival of Galileo, when you're told that you have to now make a move, choose A or B, you will look up at the moon. If the moon is in state 1, both of you look up and look at the game in state 1. The dominant strategy in this game is A. 4 is better than 1. 101 is better than 98. You'll play A for sure. If the moon is in state 2, both of you will look up at the sky, and B is the dominant strategy. 103 is better than 102. 2 is better than 1. Both of you will play 2. Which means half the time you're going to get 4, half the time you will get 2. Your average payoff is going to be 3, is your expected payoff. That scientific discovery, the understanding of what's happening beneath the game that you're playing, causes a total disruption in the payoffs. Where is it coming from? It's the reminder that what is true for a Robinson Crusoe economy, very often in microeconomics we work with the Robinson Crusoe assumption. An individual gets greater knowledge, you will of course be better off. You know how to use this knowledge. But in a strategic environment where there are different individuals with different motivations going around, a knowledge breakthrough, which is just scientific understanding of the world, can cause things to backfire on your face. That is the paper that is published. It's called the knowledge curse. This is the curse we are talking about. Where do we go from here? Within this paper, and I'll tell you very, very briefly, there is, we pursue 2 different things. I will, let me get to that and I will explain. actually, let me quickly put in a footnote, which is the same problem. We had earlier played around with this, but my co-author loves strictly dominant strategies, so we went for the other game. We could do exactly the same exercise. We call this, it's not in the paper. We talked about this as a yin-yang game. Suppose the base game was the top one. No matter what you do, your expected payoff is 50. You will do anything, the other person will do anything, you will get 50. That's your payoff. Now let us say that Galileo arrives and says, it's 50 is the expected payoff, but beneath that, if the moon is in state 1, the game is the one in the middle, and the moon is in state 2, the game is here. The expected payoff is 50-50 no matter where you are, and you can see what's going to happen. In state 1, you will look up and both of you are going to play A. In state 2, you will look up and both of you will play B. Your payoff is going to crash to 1. Exactly the same thing that I was showing. This is a clean game, 50-50, 50-50. And two prisoners' dilemma turned around and jammed together is what is giving you the base game. The base game is nothing but yin prisoner's dilemma, yang prisoner's dilemma, jammed together, you get to the base game. So that's the same story told even more simply. But the paper then, this is the central result which got us excited, and we worked on this paper actually very quickly after that. I want to tell you some directions that we have pursued. Let me put this, and after that, we've gone in two different directions in the paper. Very short one is my co-author, Jürgen Weibel, is an expert on evolutionary dynamics in game theory. So we had to do a little bit of evolution, and there is a bit of a surprising result. I'm going to tell you, I don't know how much a part of your curricula is evolutionary game theory, so I won't display any algebra. Anyway, it's not something I do centrally, but I do a little bit. Let me just verbally tell you, you get some interesting results if you take exactly the same base game and the dynamics, not the yin-yang version, but the earlier one I showed, and allow for evolution. Evolutionary game theory, maybe this will be repetition for some of you. After we had worked this out, we wanted to see in a society where people are evolving, what happens in the long run with knowledge. And the question that you will probably know, it began in economics. There's a very clear first day for the paper. Nature, the journal, in 1973 published a paper which is Maynard Smith and George Price. John Maynard Smith and George Price had this paper, which Maynard Smith is a pure biologist, and they write up this paper, which is a biologist writing on using game theory. Very, very elementary game theory. Maynard Smith, I met him when he was at a doddering old age at a conference. Delightful person. I was easygoing, happy-go-lucky. He had spent a big chunk of time in India. Very left-wing activist kind of person, but his work has no reflection. It's pure theory work for him. Maynard Smith also told me, I must tell you, for me, it's stuck in my head, very touching. Those of you who are in research has its difficult times. I asked him, how did you get onto this paper? It's so far away from your field, game theory, because this is the first time evolution is being brought into society formally and game theoretically, and explanation being given. He told me that George Price, his co-author, had submitted a paper, I'm now forgetting to which journal, maybe even Nature, a paper which he had refereed 10 years before this paper comes out. He says he had read the paper, he felt it's very weak, he rejected the paper. Time passed, 7-8 years later, he started thinking of evolution and how game theory can be used. And Maynard Smith gradually stumbled upon a way of doing it, and he suddenly remembered this idea was in the paper that he had rejected 10 years ago. And he said he could not sleep. He just felt very, very troubled that he had killed a paper which had the germ of this, what he thought was a big idea. He went searching for George Price. George Price was a very unusual person, began as a staunch atheist, broke up with his wife, who was a devout religious, Christian religious person, and later he became a devoutly believing person, and mentally very troubled. He used to live in complete isolation. Maynard Smith said he had to look around. He's an American who had settled in London, living completely on his own, and found him living somewhere, and told him that you have to put your name to this paper I'm writing, because he said he persuaded him, but George Price would kill himself the next year. A very, very troubled human being, talented human being. Maynard Smith seemed the opposite. Happy-go-lucky, doddering old person that time. I remember he chatting with me about Prashanto Mahalanobis, whom he had met. He said such a daunting person. He had found him very difficult to interact and all that. I'm going off from my topic in a big way, but let me come back now. Their result was the following, for those you don't know. How did they introduce evolution? I like the evolutionary game theory, but I feel there's a lot more conceptual work to be done, not the mathematical part, but it's started us in the right direction, but work needs to be done. This is the way it's done. I'm good because I will show you what our result is without getting into the algebra. Give me a moment to explain. Assume people don't choose strategies. They are strategies. Meaning, take the hawk-dove game. Even if you don't know the details, the hawk-dove game is where a player has to decide, should I be a hawk, aggressive, or should I be a dove, timid, ready to compromise? Maynard Smith took the same game and said, I will play with creatures who are not choosing to be hawks or doves. Some of them are hawks, some of them are doves, because he was thinking of the animal world. The dove is a sheepish creature and the hawk is an aggressive creature. But how well they do in this game will determine how fast they are replicating over time. And by using a concept which is very close to Nash's, in fact it's a selection of the Nash equilibrium, he stumbled upon this idea and shows that hawks are not in the long run a dominant strategy. They will get driven out of society. If you're hawkish repeatedly, you will get driven out. Even doves are not actually evolutionarily stable. They will get driven out. It's those who have a trait in between, that's the strongest trait in terms of evolution, and that is the trait that would survive the longest, was the result that they had got. I'm just trying to recall, as I'm seeing T.C. Anand, we used to teach game theory. Whether we taught evolutionary game theory in Delhi school, I don't remember. I got into it much later. Now, in our paper, this is what we do. We are not fixing agents as innately always playing strategy A or always playing strategy B, which is what Maynard Smith and Price had done. What we do in our paper is take some agents to be knowledgeable and lots of agents to be ignorant. So after Galileo makes the discovery, some agents learn. So they look up at the moon and they begin to play, whereas others don't realize that the payoffs have a connection with the moon. And we want to see who has survival strength in the long run, the knowledgeable or the ignorant. So what we do is this graph. This is Jorgen Weibel played a major role in this part of the paper. We are starting with a society. The red line is a tiny fraction of knowledgeable people introduced into this society. It's like a germ coming into a society. It's very easy to show that the being knowledgeable gives you survivability. So the proportion of society with knowledgeable people will go up like this, the red curve. Is gradually society will become knowledgeable because knowledge gives you a survival strength. But our knowledge paper in the background says society as a whole becomes worse off. So the payoff per capita goes down like the blue dashed line. So knowledge does have this dominant trait, and the knowledgeable people will proliferate, but with that proliferation, welfare is going to go down. I will urge you, by the way, the paper is a very, very readable paper. You'll have to read it slowly. Most of it is with examples, so if you get a chance, do read. I am looking at my time now where I want to go. So that graph sums that up. Let me just decide. I do feel like showing you a little bit of... I got in after that into not after that, before and after I've been working quite a bit on, if you get these negative results where no individual is causing it, but are collectively negative results, we know of course the prisoner's dilemma, but you have some of those even in the moral domain, what should you do? This question I want to pose because there is no clear answer. Both in my paper with Jorgen Weibul and the paper from which I'm going to use just now is my own paper in the philosophy journal Synthes, where I discuss Greta's dilemma. We show how a group of people can collectively behave abhorrently, where it's difficult to place moral responsibility on any individual. And this does, ever since I stumbled upon this game called the Greta's Dilemma, I have been troubled, and I've always been troubled. We read newspaper headlines, we read about groups behaving badly, and we treat them as morally dreadful. It does trouble me that it is possible that group of individuals, all morally decent, can get into a group dynamic where they behave in a way that is abhorrent. What do you do about this? It does trouble me. I have to say, deep down, I am a believer in determinism. So I do believe that human beings should not be treated as good or bad. Human beings are, whatever their genes, whatever their environment, they've come through that. You may have to take action against certain types of behavior, encourage, discourage, etc. But you should not inherently judge human beings as good or bad. That's meaningless given a determinist world. But stay away from that bigger question and assume that you are fully morally responsible for the set of actions open to you. I can choose A or B, the other person can choose A or B, and that is my responsibility. But occasionally, being moral can backfire on the group in terms of your morality. This is a game. Again, you are going to get a negative result like knowledge curse. You're getting a morality curse, which opens up the big question about what do you do when you get these kinds of negative results. What should we do as a collectivity? I'm trying to squish the time that I will have to talk about what we should do, for the reason that I have no idea what we should do. I have some vague thoughts. I will put them on the table. But here is the Greta's Dilemma. It's a paper. Again, let me share this with you. Greta's Dilemma is a very easy one to illustrate, but again shows you that we treat it as being moral individually is always good. I do believe that the moral hardwiring in human beings is a must. It should be there, but it can backfire. We have to be aware of that. Here's the problem. Okay, the game on the left is called Greta's, before Greta. Greta being Greta Thunberg, needless to say. Two people are playing a game where player 1 can choose between A and B. Player 2 has to choose between C and D. In this game, there's a unique Nash equilibrium. Again, it's an obvious Nash equilibrium. There's only one pair of strategies where if the other person picks that, you have no reason to change yours. And if you pick yours, the other person has no reason to change the other person's. If you pick B and the other person chooses D, you get $11 each. You, by deviating to A, will do worse. The other person, by deviating to C, will do worse. So no one will want to move from B, D, or 11. There's no other such stopping point. Anywhere else, someone else will move out. So there's only one Nash equilibrium, which is DD. Now, Greta Thunberg comes and says that, look, you people play this game so selfishly, just looking at your own payoff. Okay, you are well off, you have 2-digit income, which is a high income. Don't worry about the other person. But think of the bystander. People who have nothing to do, they can't hit you back, but their welfare gets affected by you. Those are the bystanders. In Greta Thunberg's discourse, the bystanders will be the future generation. They get affected by your action, but they can't do anything which will affect your welfare. But also in society, and I'm acutely aware that there are people who live on the fringes of the society, who can't do anything to hit back on the people who are the dominant players. They are also bystanders. So it's the same bystander we are talking about. And Greta then tells you and makes you aware that, look, depending on the action that the two of you choose, the bystanders' welfare are given by, if player 1 chooses A and 2 chooses C, you yourselves get 10 and 11, but the bystander gets 2. And if you choose A and the other person D, bystander gets 8, 4 and 0, which means when you play this game, paying no attention to the bystander, you're giving the bystander a welfare of 4. And Greta says that, look, that person is so much worse off than you, shouldn't you consider that? For reasons of simplicity, say, player one gets persuaded that I have to become moral. And what does being moral mean? In this case, it's a consequentialist ethic that you are going to value the dollars that go to this poor bystander, which means you begin to internalize that. That from now on, player one says, the future generation's $1 is like my $1. So I'm going to play the game fully, taking into account the future generation on par with me. You can use fractions and all, it'll complicate that, but just do that. Once you've done that, the game changes because player one now is not thinking of payoffs of the 10 will now be viewed as 12, 11 will be viewed as 11 because you are adding 0. This will become 15, this will become 18. So the game, after player one becomes moral, the game becomes, the game on the left-hand side is Greta has persuaded person one has become moral. And you can see now the equilibrium that will happen after you've become moral. The Nash equilibrium is AC. You will choose A, the other person will choose C. No one wants to deviate from there. The future generations payoff that was 4 has now plummeted to 2. The person becoming moral and concerned about the future generation has the future generation penalized by this. And by the way, you can do this even if it's both of them become moral. It's not possible to do it in a 2x2 game, but in more than 2x2 games, you can have everyone becoming moral, everyone concerned about the future generation, and the future generation becomes worse off, which to me is a reminder that Greta Thunberg's moral concern is extremely important, and I do believe moral concerns, and by moral I'm not meaning religion or anything like that, just plain ethics, empathy, etc., extremely important. But also design and intelligence, extremely important. Just being moral and rushing out, it can backfire. You have to think, put your mind to design. And in a place like Delhi School of Economics, I want to emphasize that. And it's not just economics. I find a lot of this, in fact, greater interest among philosophers, sociologists, political scientists in these kinds of issues. That's important. The design is extremely important, and the paper draws attention to this. What you do about it, Ram, if I take another 5 minutes, I'm not seeing Ram any. 5 minutes, fine. I want to take a few questions. Yeah. What you do, no clear answer. We talk about this. I'll go to that page and leave it there. This is, I'm skipping over all this. Yeah. You know, we usually, we do standard economics with assumptions, two kinds of assumptions. One which we write down explicitly. If you read the ultimate book of axiomatically describing an economy, Gerard Debrow's book, Theory of Value, every trait of how human beings behave are written down in axioms, and then you derive theorems. What is forgotten? And the more I've thought about it, the more aware I am, is there are assumptions in the woodwork of the discipline so hardwired that we don't even realize those assumptions we are making, so we don't even write that down. And the biggest example of that, of course, comes from geometry. Euclid thought Euclid was writing down everything axiomatically and deriving theorems, but at least one axiom we know was so obvious to Euclid that Euclid never wrote that down explicitly, that the entire geometry is being done on a plane. So on the surface of the earth, Euclidean geometry does not work. So if we came into the modern world with Euclidean geometry and calculated when there's fast travel across the earth, we would have had major accidents because the results of Euclidean geometry would not arise. And we are lucky that there were major breakthroughs that took place, most of that in the 18th century, but there were even earlier writers, Persian writers who had stumbled upon this, and a German lawyer. This, in fact, it often helps to be an untrained person to hit upon these, who realized that Euclid had used an assumption without realizing, and then Gauss and others, Riemann, come in, and the full algebras developed. I feel economics is riddled with that. I don't have time. There are assumptions that are so hardwired we don't look into it. And a part of it is our normative, moral hardwiring. We take it for granted. And the thing that we have to look at when we encounter these kinds of problems is two kinds. One is prior agreements. A constitution to me is a very good step to take action against if there's a sudden discovery which lurches the world towards a bad outcome. If we have a prior agreement among us how we will behave, then that helps. And the prior agreement, some of them, I've got it on the PowerPoint but don't have the time, can be done in a very standard game theoretic way. Groups can get into agreements to give up certain actions using the logic of Nash. You agree, I'll never do these things. Certain set of actions, the other person says, I'll never do another set of things. And this giving up of actions together constitute an equilibrium. If others give up, it's in my interest to give up. But we need to go beyond deliberate self-interest to the moral hardwiring, to the norm. Norm is a better word. Moral is such a loaded word. Normative hardwiring of us, and rethink that given the pitfalls that the world faces, we need to step into these, get human beings to be aware of this. And even when a bad result is discovered, discovery is made, say a scientific breakthrough, or in the knowledge field, a breakthrough, or like I showed just now in Greta's dilemma, someone becomes moral. If we have a prior agreement on certain norms to kick in at that point of time, there is a chance for us to survive. Whether that will happen, I don't know, but I feel these papers, these two papers, open up these big questions, very open-ended questions, and I would love to urge you to take a look at this. With that, let me stop and I'll take questions. Thank you. Yeah.
So, sir, my name is Raghav Harjai.
Yeah.
And I'm a first year student at DSE, MA Economics. My question is, sir, as you said that as per the Euclidean geometry, there are many assumptions that, that were wrong actually, or that were not complete actually. Can you tell some assumptions in economics that are not complete or that can be challenged, where we can challenge the status quo basically?
I can give you a very good example in this. Trade between people, when does trade take place? Go back to general equilibrium theory, whether it's Gerard-Debreu or Edgeworth-Bowley box analysis, you need basically two assumptions. If people prefer more to less, you need greed. Then the indifference curves are moving up, you're familiar with that. And you need diminishing marginal utility or convex preference. If you have too much of butter, the utility from butter goes down. That gives you the traditional indifference curves. So those two assumptions, more is preferred to less and diminishing marginal utility. With separable utilities, that's the case. Now, if the initial endowment is lopsided between two people, you and there's another person, both have these preferences, economists will tell you that trade will take place with this if the initial endowment is lopsided. So you've got all the butter and the other person has all the bread, and the logic is very easy to see. Butter gives you satisfaction, but after a point the satisfaction goes down. Bread gives that person satisfaction, but when that person has had a lot of bread, the satisfaction goes down. So two of you will want to trade. And you will give some butter to that person, and this person will give bread. So in economics, you have this, that if you in fact satisfy assumptions A and B, more is preferred to less, and diminishing marginal utility, trade will take place. A set of people, they were not trying to show this, but I actually refer to that in my work. It was someone called Karl Warnerried who had drawn my attention to it. A group of people in Texas had done experiments with rats. Rats, they prefer more to less. We can see them all the time. They are looking for more food scurrying about. That's taken for granted. They satisfy the first axiom. The second axiom is that these rats satisfy the law of diminishing marginal utility. There are beautiful laboratory tests showing that as they get more and more of a good, the marginal utility goes down. I won't get into the details. So rats satisfy the two crucial axioms. Karl Warnerried had written about this. I've never seen this reported, that some researchers now decided to see if rats will perform trade and exchange or not. So what they did was put one rat here with a lot of bread, another rat there with a lot of butter. And rats satisfy the two axioms which lead to trade. But within moments, they were fighting with each other and everything was scattered. There was no trade between the rats. I personally would not even do this experiment. I could tell you rats would not perform trade. They will fight. Rats satisfy the basic axioms, but they don't manage to do trade. The reason is you need much more than those two axioms which we write down. There are certain norms and respect for the other person, etc., which are hardwired in society. And I think this is just one example, but the number of norms that are, I go back to Karl Polanyi's ideas, written somewhat without the formalization that appeals to us, that economics is embedded in a whole lot of these things, and the embeddedness is extremely important. And I feel as we are getting into today's conflicting times, we have to get back and understand that the way economics is embedded.
Thank you, sir.
Am I audible? Hello,
Yes.
sir. Thank you for this lecture. I had two questions. First, when you say that we need to sort of have pre-agreements on how will we behave when we are when we come across new knowledge. So my first question is, won't rational agents take this into account? So won't this problem continue? Like, you gave a solution, but my question is, won't rational agents take that into account? And the second is, when you were talking about Greta's dilemma, there are a lot of factors which economists don't take while considering utility. So, for example, if today's leaders think that we should cut down on our coal consumption or carbon emissions, sure, it might affect other processes, but we might be leaving the future generations with a better environment. So, my question is, in a nutshell, that the payoffs that you draw, they might not be incorporating other aspects which may affect well-being. So, what do you have to say about that? Thank you.
See, very briefly, the first thing that you said is that when you get into an agreement, players know that you've got into an agreement. They will take account of that. The agreement has to be done in a way where that's taken into account. And game theory, the one part where game theory is very strong is in these consistent systems. So the example I was giving earlier, if I say that I'm going to give up certain actions, I will never undertake that. Behaving in a certain way, etc. And Arunava says he's going to give up 3-4 actions. If this giving up is a Nash equilibrium in spirit, then it means if he gives those up, it's in my interest to give these up. I have no interest in using this. So giving ups can constitute a Nash equilibrium. So no matter after that, how much rationality you use, you can't break this. And another reason why constitutions are important is that constitutions have a trait that they try to mimic, whether you call it Gandhian principle or Rawlsian principle, where who the person is should not matter in the law that you've drafted. It should not matter whether you are being affected badly or someone else is being badly affected. The religion of the person, the caste of the person, nothing should matter. A person is a person. It should be an independent rule. Very difficult in life to do that. But in a constitution, the only advantage is, since we are drafting a rule for the next 500 years, our self becomes relatively more minor, relatively. So there's a bit of a chance that you'll do that. Your second question is a much more complicated question, and I have to say I'm not fully on page with this. Yes, there are many other domains of action, and we are ending the paper by saying that we have to understand these better so that we can build those into our analysis, but I don't have a full answer to that.
Sir, I have 3 questions. I'll try to be as brief as possible. So, in the first game of knowledge curse, you said that you provided a scenario that there is a section of knowledgeable people, and there is a section of people who are completely ignorant. If I have got this understood it correctly, but I think that if there could be a scenario where, in case of half knowledge, like that people might have half knowledge, in the sense that they might pretend that they know a thing, but in the end they don't. And I think that's more likely the case in the society that we live in. So how can that result, how can that impact the result of this game? Another question is on the Greta's dilemma game. So in the first scenario, you just said that there are a group of friends who are they are playing their strategic games, but they are not taking care of the bystanders. So how could the result change if there is an agreement between those friends and the bystanders, if they cooperate on some grounds? And the third question is that in the last slide that was shown, so there was a line, if I'm not wrong, that there is no there is no universal set. So like, could you just throw a light on what you wanted to say? Because in economics we quite come across this term, the universal set. So what's it? So
The first one, I'll tell you, I was not constructing a case where some are knowledgeable, some are not. I took a special case later. Our central paper, my paper with Waibul, is where everyone is ignorant. Galileo comes, everyone becomes fully knowledgeable. What you can ask over there is, instead of becoming fully knowledgeable, if they become partially knowledgeable, some Bayesian notion, and you have a partial knowledge, what will happen? I often don't know the answer, but I have enough intuition in this to feel you'll get a similar result. You'll have to put pen to paper and you'll get it, but I haven't worked that out. The second one, Greta's dilemma, I didn't say friends are playing this game. It's a group playing this game, but group playing this game. If they have an agreement with the bystander, is no way to go, because the bystander has nothing to do. Bystander takes no action, just takes. So you don't need to tell anything about the future generation that, look, you have to behave in a certain way before I do that, so that won't. Your last question is a deep question. In game theory, it was started by Ken Binmore, an expression which has become a part of it, that there's something called the game of life. The game of life is a game where all possible actions of all possible people are a part of the game. So the whole world right now is involved in the game of life. That's the description by Ken Binmore. My trouble over here is a belief that I have. It's that there is no such thing as the game of life. We pretend, and I reached this conclusion from an analogy with mathematics. In mathematics, in the early maths, they would wave their hand and say, let us start from the set of everything. So you're doing set theory, start with the set of everything. Okay, that became a part of it. You took for granted, let's start from the set of everything, the universal set. Then you began hitting upon paradox. One paradox after another, strange results. It struck Bertrand Russell that the implicit assumption they were making is causing all these paradoxes. The assumption that there is something called the set of everything is a false start. And mathematics now, you use universal sets, but these are constructed. I will assume this is the universal set and won't get out. We don't wave our hand and say, consider the universal set. In game theory, we do that. And what you saw in the PowerPoint, I didn't have time to go into, is a discussion that even in game theory, we have to recognize that there is no such thing as the game of life. There's always, you can go beyond what you've written up. And some works of philosophers, contemporary philosophers in America, they don't have the formalization of the way game theorists do, but are getting into this idea, and for me, that is a direction to explore.
In the Greta's dilemma, the payoff metrics the numbers that you have in the payoff matrix for the future generation, that you choose, how do you choose that? Is your result dependent on the choice of the numbers in the payoff matrix, or is it a general result? It is not a general result.
No, it's not a general result. When I stumbled on this result, it interested me that if future generations are affected in a certain way, then being concerned about the future generation hurts the future generation. That was exciting enough. So I wrote down some numbers. But now I have done some generalization. You can get classes of games where you will get, so not as precise a payoff, but of course, I'm not saying that this happens all the time. But it can happen, and we should be aware of this when we construct our rules, regulations, and draft constitution. It's a possibility. Jean had a question.
Jean, would you like to go first?
It's a question about the teaching of economics in reaction to your concluding comments, which I sympathize with. You said that there are a lot of embedded assumptions in the models that we work with, and I think that's certainly very true of general equilibrium theory, which has a huge influence on the way we think. and for that matter, true of game theory as well. But isn't it a bit strange that when we teach economics, we don't talk about these embedded assumptions, and then it takes people like you and me 20, 30, 40 years to open our eyes to the blinkers that we have developed? And can't we do better to, at the teaching stage, help students to see these assumptions? Because otherwise you're training people to be blind to these embedded assumptions, and the biases can be quite serious. So I'm just to give an example, you mentioned Polanyi. Polanyi certainly sounds like a helpful author to read, to understand some of these embedded assumptions, but I don't think we teach Polanyi, right, in economics, at least not in my days at all. So would you agree that there's something we have to change a little bit the way we teach economics if we want to address that problem? I'm just curious.
No, I agree actually fully, but I'm also going to put in a caveat. I now always give a little bit of Polanyi, and there's a contemporary writer, Mark Granovetter, some similar ideas of embeddedness, very beautifully done, bit closer to our language, easier to follow. So I do that now. So after having done damage for 30 years, not having done this, I now do it. Whenever I teach, I do remind people. But Jean, there is also maybe an endless problem. We also have our own hardwiring. So even when we are sort of getting out of that, some of that comes, but that's what life is. But I agree now, I'm very sensitive. So in my microeconomics, I put in a lot of these kinds of awareness. Thank you.
Wondering if I could ask you a question, which is how would you respond to what I would say would be a Kantian critique of your discussion of morality? So the idea is that, the normal form and the thinking that goes behind the normal form is not the appropriate way to think about moral decisions. The way that you should be thinking is what happens, in the normal form way of thinking, you say, well, if I switch from action A to B, given my beliefs about what the other guys are doing, how is my payoff affected? But what you should be asking is, what would happen if I move from A to B and everybody else also moves from A to B, right? Then how would the world look? Rather than this sort of standard normal form way of thinking, which is that I have these fixed beliefs, and those obviously cannot respond to the way that I'm thinking about choosing action A or B. So how would you respond to that?
Yeah, there's one class of papers, I don't know if you know that, it's in fact Weibel and Alga on Homo Moralis, they call, where they build into games this. But here is my problem. Deep down, I am conflicted about Kantian ethics. Because deep down, I'm a consequentialist. So I like to think of any action that I take, does that help to be a better world? And when people say that, what if everyone else behaved like that, would it be good? To me, if everyone else is not behaving like that, why should I think? So I have this problem. Now I have reached a position, which is Derek Parfit among philosophers has this, that little bits of actions, each taken consequentially, can lead to a sequence of actions which are collectively consequentially bad. So I like, in the end, everything to be reduced even in more complex ways to consequentialism, rather than Kantian ethics, where deontological ethics, where you're thinking of rules, the rules may be derived by everyone else's behavior. That remains an exercise in my head, not totally persuaded. Yeah.
Okay, we can discuss this,
We'll
I
have
guess.
to, yeah.
Okay. Any last question? Okay.
So, good morning. My question to you is from the last slide, wherein you said that the constitution as an arrangement can help pull back groups from outcomes that might not be good for the future generations, etc. But so my understanding of it was that this can work if the constitution in itself was designed in an egalitarian manner, and even if it's even after its design, its enforceability needs to be taken into account. So my question to you here is, what sort of measures should one take in order to ensure that the design process is egalitarian, takes all groups into account, and post the designing, how can the enforceability mechanism be designed?
Yeah, I'll start with the second bit. The enforceability, there are two kinds. One is very standard game theoretic structure, you can do it, which I said very quickly. I also had one page with a game which I didn't have time to get into. Certain kinds of enforceability are self-enforcing, which I'm saying again in words. If Arunava gives up actions X, Y, Z, and I say I'm not going to take actions A, B, C, it may turn out that given that he's given up those, it's not in my interest to take ABC. Given that I've given up ABC, it's not in his interest to take those actions. So, certain constitutions are like a set valued Nash equilibrium. The set of actions I've retained, the set of actions he's retained, set of actions she's retained, Pami over here, we've done this. These sets are self-enforcing. So you can do a lot of thinking of constitutions in standard game theoretic terms. But what I touched on, in life there are actions beyond what we think of. The set of actions is not, there's no well-defined universal set. So you need enforcement mechanisms probably very often in real life. How do you do it? Again, I'm on the whole a skeptic about virtually everything in life. I don't think there's a clear solution that this is the way to do it, it'll be self-enforcing. We'll have to live in life with these uncertainties. You try to do the best. The other thing that you said, how can it be egalitarian? There's no obvious reason why a constitution will be egalitarian. A group of people can create a constitution which is in the interest of their own class or their own, it is possible. There we just hope that people coming up, voices of good people, will be exercised and will happen. Again, there are no guarantees. I don't feel sure that we will get out of these problems, that there is a way to get out. I just hope we will do so.
But then it is possible that even after the constitution has been designed, it is disseminated to a large number of large sections and it go much closer.
It is entirely possible. It is possible that a society will create such a constitution which is designed to help a small group, and it continues to do that, so society becomes worse off. That is a danger you have to look out for when the constitution is being drafted, indeed.
Okay, so I think we should conclude now. Thank you again, Kaushik Da, for a wonderfully lively and entertaining discussion. Thank you. And congratulations to the Delhi School of Economics again. Okay, thank you.
Thank you so much, sir, for your kind words. To proceed further, in this session of the conference, today we are delighted to have with us the former DSE directors, whose journey here has left a legacy of inspiration, setting a high standard for those who follow. Thank you for steering us towards greatness with your unwavering dedication. We start with our senior most director, Professor K.L. Krishna. Professor K.L. Krishna joined the department on 7th August 1959 and retired on 31st August 1994. During his association with the Delhi School of Economics, he remained head of the department from 1980 to 1981, and again from 1982 to 1985, and the director from 1993 to 1995. Thank you, sir. Next, Professor Om Prakash. Professor Om Prakash joined the department on 16th July 1964 and retired on 31st July 2002. During his association with the Delhi School of Economics, he remained head of the department from 1989 to 1992 and the director from 2001 to 2002. Thank you, sir. Next we have Professor Pulin B. Nayak. Professor Pulin B. Nayak joined the department on 1st July 1978 and retired on 28th February 2015. During his association with Delhi School of Economics, he remained head of the department from 2000 to 2003 and the director from 2005 to 2008. Thank you, sir. Moving on, we have Professor Santosh C. Panda. Professor Santosh C. Panda joined the department at 1st April 1985 and retired on 31st December 2019. During his association with Delhi School of Economics, he remained head of the department from 2005 to 2008 and the director from 2011 to 2013. Thank you, sir. Now, Professor Meenakshi Thapan. Professor Meenakshi Thapan joined the department at 1st September 1989 and retired on 31st September 2019. During her association with Delhi School of Economics, she remained head of the department from 2004 to 2007 and the director from 2018 to 2019. Thank you, ma'am. Now, we have Professor Pami Dua. Professor Pami Dua joined the department at 14th August 1996 and retired on 30th September 2023. During her association with Delhi School of Economics, she remained head of the department from 2010 to 2014 and the director from 2013 to 2018 and again from 2020 to 2023.